Good day everyone, my name is Louise Bergabeña and I'm here to present to you the architecture of my Laravel project. I will explain to you how the general workflow goes in my system, and basically the premise of my system is that the user can perform basic CRUD operations and then add products, and it will get reflected in a table on the browser or the Laravel front end. And as you can see here, there are two sections, the front end and the back end. I will explain to you how these work hand in hand. First, you can see here the browser, the Laravel views, and the HTML. This work together so that the user can see what is being reflected by the back end. So first of all, if the user were to add a product, the browser will send an HTTP request or an API call to the back end, and then in the back end, what handles these API calls are the controller, since the controller is responsible for the whole business logic and the functions are in the controller. Let's say for example the post function, since the user wants to add a product to the database, and then the business logic will get passed on the model, and then the model is what goes to the MySQL database and alters or performs the operation that is being desired by the user. Let's say for example the post operation. The post operation, the model will then add that product with its corresponding elements or attributes in the MySQL system. And in order for the system to reflect back the data to the browser as a table, as is the database will send the data results back to the model, and then the model will then send these as data objects or PHP objects in order for the data to be successfully let's say put in a table by the controller. So then the controller then sends the data to the browser, wherein the HTML will work hand in hand in order for the data to be reflected neatly in a table. So basically that's how my project works. So to recap, the browser sends a request to the controller then tells the model what to do, and then the model will alter the database based on the given instruction of the controller, and then the database will send back these results to the model, and then the model will redeform the data as data objects, and then the data objects are going to be sent to the controller, and then the controller will forward the data to the browser so that the browser can then show the user the data that is present in my project. So that sums up part 1 of the activity. As for part 2 of the activity, here is my 2-floor network diagram. As you can see here, with each floor having 10 PCs each, and here's how I configured this network. As you can see here, on floor 1 there are 5 PCs each connected to a hub, and same goes below, and these 2 hubs connect to a floor switch, where the switch then connects to the building router. Same goes on the left, 10 PCs, 2 hubs, and the switch connected to a router. So basically the only thing that's different here is that these 2 floors have different IP address ranges. As you can see here on floor 1 PC1, if we check the IP address, it has a 10.2 IP address no, and then the next PC, the PC beside it has a 10.3 IP address. So basically the gateway of these PCs is present in this department router, since we configured it already. If you can see here is the 10.1, because the 10.1 is reserved as a gateway for this network. So meaning this network is already configured to this router. So meaning the internet access will then flow to each of these PCs, and then they will have an internet access. And same goes to this side, but the IP address is .20. The ranges is .20. So you can see here the first PC is .2, because again the .1 IP address is reserved for the gateway. So let's check if there is a floor-to-floor connection or communication between the PCs. We can do that with the command prompt ping 192.168.10.5. So you can see here there's a reply. Then that means they can communicate with each other. These PCs can communicate with each other. And same for PC. Floor 2, let's check if there is a floor-to-floor communication. At 20.5, there is a floor-to-floor communication. Now let's check if there is a different floor communication from floor 2 PC3. Let's ping 192.168.10.2 if we can reach. As you can see here, it took a while, but there is a reply from PC2, and that's how these PCs can communicate with each other, being connected to one router. So basically, the internet flows to each and every PC despite having different floors and different IP addresses range, if you configure it this way. And that's my presentation for the activity. Thank you everyone, and God bless.